Contribution Plus, and welcome back to this S.4 Mathematics. We are looking at application to kinematics and calculation of velocity and acceleration. Example 4 part A says a particle moves upwards vertically. Okay, the particle moves vertically upwards such that at any time t seconds its height h meters above the ground is given by. So part A, we have a particle that moves vertically upwards. It moves vertically upwards, straight upwards, okay? Such that its distance from the ground at any time t is given by height, okay? Its height above the ground is given by negative 5t squared plus 30t. This is the expression for the height of the particle above the ground at any time t seconds. That is the expression for the displacement. Now the displacement is in terms of height. We are displacing the particle upwards. Now the question can guide us. The question says calculate its velocity at time t is 1 second at a time t is 3 seconds. So it asks for velocity. Now, for us to get the velocity, we need the expression for velocity at any time t. That means, remember the height, like in this case, represents the displacement. Velocity is the rate of change of displacement. And in this case, velocity is the rate of change of the height of this particle that is thrown upwards. Therefore, velocity will be given by dh dt. This is the rate of change of height. In other words, it is how fast the height changes with change in time. So, velocity in this case is the rate of change of height. Now, that means we need to get dh dt. We get the rate of change of height. Therefore, dh dt we simply differentiate the expression for the height at any time above the ground. That gives us negative 10t plus 30. If we differentiate that, negative 10t plus 30. This is the rate of change of height with respect to time. Therefore, it is the same expression for velocity, negative 10t plus 30. This is the expression for velocity at any time t. Okay, this is the expression for velocity at any time t. What if now? What if when the velocity, when the time is 1 second. So when t is 1 second, what is the velocity? Then you simply substitute for t as 1 in the expression for the velocity. Therefore, we shall have negative 10 times 1 plus 30. This here gives us negative 20 meters per second. That means when the time is 1 second, the velocity of the particle is 20 meters per second. What does it mean? If you look here, the velocity is positive. Since it is positive, it means the particle is moving in the upward direction. Okay, it is moving in the direction of projection. But that analysis is not very important for us. What is important for us is that the velocity when the time is 1 second is 20 meters per second. What about when the time is 3 seconds? Because they are fast. When the time is 1 second and when the time is 3 seconds. If the time is 3 seconds, you come and substitute in the expression for velocity at any time. So that the velocity when the time is 3 seconds becomes negative 10 times what is your time? Your time is 3 and then plus 30. plus 30. Then what are you getting? 0, right? 0. Negative 30 plus 30, it is 0 meters per second. What does it mean when the velocity is 0? It has two implications. One, it is either the particle has reached the maximum height or the particle has come back to the initial position of projection. It has come back to the ground. Those are the two implications. Okay? It's either the particle is at the maximum height or the particle has fallen back to the ground. But for now, that is not our focus. So when the time is 3 seconds, our velocity of the particle is 0 meters per second. That was for Roman 1. Roman 2 says, how far does the particle travel? Remember, this is a particle that we are throwing upwards. So how far does it travel? The distance, because remember, when you throw something up, it reaches a point when it falls back, right? If I throw this calculator up, it will reach a point and then it begins to fall back. Now, the point, the maximum point before it falls back is what we are calling the maximum height. That is the maximum height or the maximum displacement from the ground. And just before the particle returns or falls back, okay? Just before the particle falls back, it must first stop momentarily. You throw it up, there comes a point when the particle stops and then falls back. So the point when the particle stops gives us the maximum height because there is no height above it. That is the maximum height. So at the maximum height or at the maximum point, the particle goes to a state of rest momentarily. It takes a very short time because the force of gravity pulls it back. So what is the takeaway here? The takeaway here is that at the maximum height, the velocity is 0. Okay, that is the final velocity in this case. But it is not good to call it the final velocity because there is another second motion waiting, that is falling back. So for now, let me call it the maximum height. Okay, the maximum height. So the distance or the far or the displacement, the height that the particle will travel is what we are calling the maximum height. Is the maximum height. Okay, it is the maximum height. Now, how do we get the maximum height? Now, we have said that at the maximum height, the particle is momentarily at rest. That means the velocity at the maximum height is 0. Okay? At maximum height, I don't want to call it the final velocity. At maximum height, then we say the velocity is 0. At maximum height. Why? Because the particle stops and then begins the second phase of motion, that is falling back. Now, how far does the particle travel? It is the maximum height when the velocity is 0. Now, let us get that time. Let us get that time when the velocity is 0. This is the expression for velocity at any time, that v is negative 10t plus 30. Okay, this is the expression for velocity at any time of our motion. Now from here, at the maximum height, the velocity is 0. So let's get the time at the maximum height for which the velocity is 0. Therefore, here we shall say 0 equals to negative 10t plus 30. And then we make t the subject of the formula. This is just a simple linear equation. I'm saying my t here is 3 seconds. Okay? My t here is what? It is 3 seconds. That means for the particle to reach the maximum height, it must be given a duration of 3 seconds. So the time at the maximum height is 3 seconds. What is now the maximum height? The maximum height is the height when the time is 3 seconds. Therefore, we use this time 3 seconds and then we get the height at the time 3 seconds. Why? Because 3 seconds is the time when the velocity is 0 and the velocity is 0 at the maximum height. So from our expression for the height above the ground at any time t, which is 5t squared plus 30t, let us substitute for the time of the maximum height, and that gives us the maximum height. So here shall have h now was negative 5. Our t now is 3 squared plus 30. Our t here is also 3. Then we find that 9 times 5, negative 45 plus 90, I'm getting 45 by simple assessment. 45 meters. That is 3 squared times negative 5 plus 30 times 3. 45 meters. So 45 meters is the maximum height, and that gives us the how far the particle moves upwards. Therefore, the particle, okay, moves how far does it travel? So the particle travels 45 meters, and that is the solution to example 4a. Always feel free to reach out to us so that we can guide you. We shall assign for you a tutor who will tell you through every step of the way.